data quality of service. Just as a quick recap of what we'll be looking at, I'm going to be focusing down on how we can apply quality of service at different levels of our application architecture. We'll be looking at how we can use Diffusion to manage the quality of service for consuming event data with a focus on throttling and conflation of event feeds. We're going to look how we can use some of Diffusion's data enrichment capabilities to facilitate quality of service at a data model level, how we can expand and filter data for consumers. And we'll also be looking at how we can use Diffusion's role-based security model to apply quality of service at a higher level across various classes of consumers. And finally, we'll be using one of the new features in Diffusion 6.7, session trees, to tie together some of these different features and show how you can build a comprehensive multi-tiered application model. So to start with, why does quality of service matter? Well, quality of service really is talking about our user experience, the quality of experience. And user experience is absolutely key for product and business success. A study that Amazon conducted, for instance, found that for every 100 milliseconds of latency, they saw a 1% drop in sales. Now, 1% at Amazon scale is already a lot of money. But you consider that even a second delay in data, that's 10 times 100 milliseconds. That means 1 second data latency equated to 10% loss in sales. Clearly, how quickly we can move data matters. And so how you deliver the data is a key part of ensuring that quality of service. The more efficient the delivery of data, the faster the event feeds you can provide, the more reliable the event feeds you can provide, and the greater the success of your product business from a UX experience. And some great examples of where this really comes to the forefront is things like stock trading applications. You need those prices to be instant. Critical alerts. You don't want notifications that there's been a service outage or some other important event has occurred arriving to you several minutes late. Even with messaging and chat applications, timeliness makes or breaks the viability of one product in that space versus another. Finally, things like location and ordering. If you're ordering an Uber, you don't want to find out that your driver's been waiting outside 5 minutes after he's just left. So timeliness and the quality of your data really, really matters. So how does that tie into Diffusion? Well, at a high level, Diffusion, which is our intelligent event data platform, really is based around 3 fundamental concepts: connecting data sources, enriching the data from those sources, and then delivering that data as real-time events. So what do? We're a holistic Pub-Sub platform, and we provide that consumption, enrichment, and delivering capabilities through various aspects of our product. Our data gateway has pre-built adapters, SDKs, and APIs for you to connect various different data sources. Our data wrangling capabilities, which we'll be diving into today, provide the ability to dynamically set up rules and modifications on that data. And finally, our efficient data distribution piece, our SDKs and APIs, allow you to integrate and consume that data in any downstream application. So where we manage quality of service really is coming at the end of the overall application architecture. We have data coming in from various sources, various different platforms and tools. You have your internal business services. But it's that final piece where the data is being sent out from your application tier over the internet and down to your web, mobile, and IoT devices that Diffusion really helps enforce better quality of service. Like I mentioned, we're going to be looking at using Diffusion for managing the quality of service for event delivery, for data enrichment, for access controls. And we play a key part in each of those areas, not just facilitating better or more complex behavior, but also making this simpler to introduce, to essentially being a plug and play mechanism. And we'll take a look at what that looks like later too. So for the first step, let's look at a very common scenario that we often encounter with our customers: the quality of service for consuming event data. Now, very often, we'll have customers with various upstream event sources. Sometimes those event sources might be ones that you control. Sometimes they might be event sources from other vendors or separate teams that you don't have a direct relationship with. And often those event sources, especially if they're designed for inside the network, will have a very high tick rate, high frequency that isn't necessarily ideal for your downstream user-facing applications. If you consider something like Kafka, which is very often a fire hose of real-time events, that's exactly what you want inside the network. But if you want to have a mobile application that can display that same data, you don't want to have every single update being pushed all the way through to that mobile application. It will typically overwhelm either the bandwidth and the network capabilities of the application, or sometimes the UI just isn't capable of displaying that high of an update rate. It may make sense from a data perspective to have one event every 10 or 100 milliseconds, but UIs may need slightly less frequent updates in order to present a more stable view of the data to the user. So how do we consume that event source, but then deliver something at a more sustainable rate to these downstream applications? So the solution with Diffusion is to apply throttling policies. Now, what we can do in Diffusion is take a source topic, which is coming from our upstream event source, and we can apply what is called a topic view, which is essentially a transformation to create a new topic based on the source, but one that reduces the rate of updates, that throttles it. And this gives us a couple of really key capabilities. It means that we can apply this dynamically on a source without having to update that upstream event source itself. So we essentially have independent control now. We can modify this throttling. We can test it out at one rate, see how that works, and then change that on the fly. Again, without having to modify the upstream or the downstream consumers. And we can also create as many of these as we want, which is fantastic if you want to apply different tiers of service. So let's take a quick look at how this actually looks in real life. So here in Diffusion, I have an example data set. And of course, my example code stopped working a moment before I tried to run it. Apologies. Let's see if that worked. Here we go. Okay. So here in Diffusion, we have a sample data feed. Now this is representing one sport a sporting event match. We have many customers in the space who offer live sporting data. And this is a fairly representative sample of the kind of payloads that are exposed through the APIs. We have the game, we have the various player details. And if we scroll all the way down to the bottom, we also have certain details around the game itself and different teams. Now, this is clearly a large payload. There's a lot of data here. And if we're sending frequent updates, that is a lot of data that we're sending to every consumer on an incredibly frequent basis. Here, for instance, I'm updating this every 200 milliseconds. So that's 5 times a second that we are potentially sending this entire JSON payload out to consumers. Now, with Diffusion, we have one of our unique capabilities. It's called delta compression. What that means is that we only send the changes in a payload to our downstream consumers. So we're already getting quite a benefit from that. If I look at our metrics for this, we're seeing a 99.8% compression ratio. So we're sending only 0.2% of the full payload with each update. But let's say we're in a situation where we need to control that even more. We're even more sensitive to update frequencies. I can apply a topic view that will throttle this. So I can easily go to the topic views tab. I can add a topic view. And here we're going to map our source. We're going to put that to a new topic path. We'll call it throttled match. And then we're going to add a throttling parameter. Now here we can specify that we're going to throttle sending only one update every second. If I add that view, go back to our browser, we can see the topic views are case sensitive. And if I update that, we now see the throttled path here. Now, this is exactly the same data as our source topic. But if I subscribe to this, I can go back to our subscriptions tab. You can see that whilst this top one has been updated on a very frequent basis, it's constantly flashing green with each new update. This lower one, the throttled topic, is only being updated once per second. And if we scroll down to the bottom, you can see the timestamp field on this source path is being updated very frequently, whereas we're only seeing a lower rate of updates on this throttled one. Now, throttling and diffusion can be changed completely dynamically. So let's say we wanted to go back to this topic view. We could modify this to be every 5 seconds. And just like that, we can see that our updated topic, our throttled topic, is now having an even lower rate of updates being applied to it. And this means that we could develop an application. We could have it based around this throttled topic. And based on production analytics and telemetry, if we ever needed to change that throttling amount, be it making updates slower or potentially making it faster, we can apply that change at Diffusion without having to update any end user applications. And we can do that very easily in just a few seconds. Now, there's an additional aspect of using topic views, which is that we can have multiple. So just as I showed you how easy it was to change one throttle topic from one update every second to one update every 5 seconds, we can easily imagine how we could use this to create multiple tiers of topics. We could have 2 topic views that provide a high quality tier, one update every second, and then a lower quality tier, one update every minute, or every hour, depending on the need. And of course, you can add and remove these views however you want at any point in time. So if you need to expand your application to facilitate different tiers after you've already gone into production, that doesn't present a challenge. All you have to do is create that view, update your applications to subscribe to those lower tier topics, and away you go. Now, one aspect of throttling that's not immediately apparent, but is very important to the overall quality of service, is how we actually go from 5 updates a second to 1. In a naive solution, we might just discard or throw away all the interleaving updates. But that would be pretty bad, especially if we want to have live data feeds. Typically, we still want each subscriber to these topics to get the most up-to-date data. We just want it less frequently. So what throttling does in Diffusion isn't just to restrict the flow of updates, but it's also conflating updates. What we mean by conflation is that we merge all of those messages that have been published to that topic in the time window of the throttling and combining them together. So by way of example here, let's say we're throttling to a 1 second time window. Our first message comes in and we have 3 keys in that JSON model, all set to the value of A. We get a second message published to that same topic, which only updates key number 2 to have a value of B. We get a third message. That's updating the third key with a value of C. What will get published and displayed to all of the consuming applications will be a combination of those 3 messages, where key 1 is A, key 2 is B, and key 3 is C. And this is handled completely automatically, but it means that no matter how much you restrict the flow of data, whenever we do send an event, it's going to carry the most up-to-date value for that topic, especially in the scenario of, say, sporting data, for instance, or even, let's say, market data with stocks, buying and selling prices. If you're throttling those events, you want the message that gets sent to carry the latest buy and sell price, the latest game score. And that comes completely automatically with Diffusion. So to recap, throttling and conflation help us reduce the bandwidth of consuming applications. Topic views give us a dynamic way to manage these throttling policies. And above all of that, Diffusion makes it simple to offer multiple tiers of update rates. What this means is that you can manage the quality of service for your data delivery on a per consumer basis in a completely dynamic fashion. Okay. So let's move on to the second concept, quality of service through data enrichment. So another common scenario that our customers face is having a very large data set of high-level topics. So like we just were looking at, you may have a topic set that has lots of sporting events, and there may be dozens, potentially even hundreds of those. If you're in the market, line items, you have any number of currency pairs or other assets that you want to be exposing as topics. And the problems that our customers face with this isn't managing the number of topics there, but it's that these topics represent a very high level view of the data model. And like we just saw in Diffusion, these topics can have a very large payload, very, very big JSON values, which means a lot of data is being sent to any subscriber, regardless of whether or not they're actually going to utilize all of that data. So what we're going to look at now is how we can use Diffusion to automatically filter and expand some of this data and let consumers selectively access parts of your data model in a far more granular way. So let's start with that second bit, granular subscriptions. If we take a look at our data model in Diffusion, we can see that in our big JSON payload, we have this field, score. And we can imagine that in a mobile app, for instance, we may want to present a summary of games where all we show is just the score. Once a user clicks on that, they may be taken to more details, but at a high level, for certain parts of the application, we only need to see a small part of this much larger JSON value. Now, we could write some backend logic to take our event source and split it out and publish to multiple different topics. Well, that's a lot of overhead, that's a lot of work. What we can do instead is use topic views to automatically extract parts of our data and then present that as a new topic. So let me add a new topic view here and call this game score. And so we're going to map the same source topic. We're going to, let's say, put it into a filtered tree. And then we're going to use our as value mapping to point to that specific part of the JSON payload. There we go. Now, we go back to our browser. We realize once again that topic views are case sensitive. And we can see now that we have a filtered topic, which is containing only that subset of the source. Now I can subscribe to that. And we can see that it's getting updated whenever we get points to either the home team or the away team. And that is completely in sync with updates to the source topic. If we come back here and subscribe, we can see that these will be kept in sync. We have the score here, we have the score there. I think every 15 seconds or so, we should see an update to that. Now, what's interesting too is, although we're still getting 5 updates a second to the source topic where various aspects are changing across the entire payload, here with our filtered topic, we're only getting an update when the specific part of this value changes, when there's only a change to the score. Now that's making it substantially more efficient for any consuming application to subscribe to just this score topic and get only these updates. Now, what's even more useful is that we could take this filtering, this specific score topic. And instead of having it pulling from the source topic, we could have that pull from the throttle topic that we created before. So you can chain these topic views together to throttle an event feed and then extract and filter it. And that enables you to control filtering and extraction policies completely separately from throttling. And an update to one side will affect the other. Now to go back to the presentation real quick. There's another aspect to granular subscription that I want to cover. So in some scenarios, we may not want to just extract a single payload or subset of a JSON value. We may want to do things like expanding whole arrays or objects. And we can use that as a basis for being able to allow downstream applications to subscribe to very specific topics in aggregate based on shared values. So let's take a look at what I mean by that. If we go back to our browser and we look at our data model again, we can see that we have this big array of players, covers all of the players in this game. Now they each have their own ID, name, and team. Now, what if we wanted to have a view in our mobile app that could show all the players for that particular team, or show the current stats for players with a particular ID? Or we can do that with topic views too. So let's create a new view. Do the same thing. I'm going to take the source topic, the source event feed. We're going to map this to our expanded topic, players. Now we're going to use a new feature, the expand feature. What this means is we can specify a part of that original JSON payload, in this case, the players array. And we're going to specify what key or what key and value in each array item we're going to put into this topic path. Let's start with the ID. Let's add that. And now if we look in our topic path, we see that we have all these new topics containing a single player. Again, this is from our source topic. So any changes from that single event feed will be updated here. Now, we can see a problem here that's mostly a result of the demo data model, but is a good opportunity to dive into a little more sophisticated angle of this expansion. So we have two teams, but because of the way that we're generating this demo data, we only have, or we have overloaded player IDs. So there are 2 player zeros, 2 player ones. What we would like to do perhaps is break them out by team and then by ID. So what we can do is a couple of different things here. Let's go back to the topic view that we just created. And instead of expanding them by ID, we'll expand them by team. And then we'll add a second part of the target path that we're going to be mapping these values to. We can use a scalar value, and here we'll use ID. What this is doing is essentially saying, take the array of game.players, expand every element, and put in the target path the team name, and below that put the player ID. So we should see, if we go back, if I've done this correctly, that is. Should see that here. There we go. Yes, and now you can see we have expanded players, Brooklyn Nets, Los Angeles Lakers. And if I expand this, we have the full roster of players for the Los Angeles Lakers. And similarly, under the Brooklyn Nets, we see all of the players under those two. Now, again, this is a fully dynamic mapping. We can change or rename any part of this completely at will. But what this does mean from a data quality of service perspective is that now, rather than me as a consuming application having to subscribe to all of this, getting every update for every player and every other aspect of the game all at once, I can just choose precisely what I want to subscribe to. I could choose to subscribe to one player, or I could choose to subscribe to every topic underneath Los Angeles Lakers. Of course, you may have your own mapping conventions. You may want to use specific IDs rather than the full names. But the point is that by using Diffusion's topic views to break apart your data, you now have the ability to very selectively subscribe and only use data for the specific parts of your event model that you actually need in the moment. So to recap here, filtering and expanding lets apps consume only what they need when they need it. We can use topic views to provide a dynamic way to break down your data. And it's through Diffusion that we get this flexible enrichment of the event model. Okay, so now we're moving on to the third penultimate step here, quality of service for data access. So this is taking a different view over the same general problem of how do we make sure that our applications are only accessing what they need, what they have access to. Now we've looked at how we can break apart topics and offer different aspects of our data model to consumers, but that's very dependent on our applications to pick and choose what topics to subscribe to. A very common model or problem that we see, though, is that sometimes we want to control what topics clients can subscribe to from the back end. And we may also want to break that down a little bit further. Some clients, let's say our desktop clients, should be able to subscribe to some bits of our data model. Other clients, say on mobile, they should only get a certain subset of that. Now, we can use Diffusion's role-based access controls to very tightly define exactly which topics a particular client can access. Now let's give an example here. So in my Diffusion server, I've defined two roles, tier 1 and tier 2. And we're going to say that they're allowed to subscribe to only a specific topic. So the tier 1 client can subscribe to a tier 1 topic. The tier 2 client can only subscribe to a tier 2 topic. So let's add a new user. Let's call it tier 1. We'll assign it the tier 1 role. And we can just give a very basic password. apply those changes. And now let's add just a topic view that creates those tiered topics that we wanted. Here we're just going to do a very basic mapping. Perhaps we'll put the throttled one as our tier 2 topic. So we can see here that we have our tier 1 and our tier 2 topics. Now in our basic client, we're going to subscribe. We have it connected as our tier 1 client. Now let's see if we can subscribe to that tier 2 topic. Can't, there's an error. If we subscribe to that tier 1 client topic, however, we immediately start getting that data. We can see it's coming through exactly as we would expect. Now let's go back, create a new user. This one will be tier 2. And we're going to assign them the tier 2 role. Oh. And I need to apply those security changes first. So let's connect with our tier 2 user. And again, if I subscribe to the tier 1 topic now, I get an error. If we try and go to the tier 2 topic, that works. And we're able to access that data. Now, this is all fairly standard role and permission-based security. But let's take a look. Without changing anything on the client side, we could do something like changing the roles. Maybe we'll allow our tier 2 clients to access the tier 1 topic. Now, if we try and subscribe, we have access to both. So we can use Diffusion's real-time security model to selectively control precisely which topics our clients have access to. And we can imagine that if we try to subscribe to an entire set of topics, we could use security controls to say, only make topics available to clients once a particular sporting event had started, or only when a particular market was open for trading. So we can use security access controls in Diffusion, not just to prevent unauthorized access, but we can also use it to very broadly control what topics are visible to users at a particular point in time, and to make those changes completely dynamically from the back end without any changing of the front end application itself. So to recap, the access controls enable broad management of data delivery. And this ties into quality of service by looking at how we can control precisely what data is available to clients at what time. Diffusion's roles and permission model offers a very granular control. We can expose specific topics or sets of topics in our tree to particular clients. And Diffusion has a real-time security model. We can change these permissions on the fly and have those changes be immediately applied across any connected client and any client that connects in the future. We don't need to wait for client applications to go away and reconnect. We don't need to roll out any updates to the front-end client. It happens instantaneously, just like the changes to topic views did when we were manipulating the topic model. So this brings us on to the final feature that I want to talk about today. And that's looking at how we can transparently offer different service tiers. So what we've seen over the course of this talk has been using topic views to break apart topics, to throttle them. And that's all well and good. But it ends up creating a set of topics that our front-end applications have to know what to subscribe to. If we have multiple tiers of service, let's say a low throttled topic and a high throttled topic, our client applications still need to know which tier of topic to subscribe to, which makes it difficult if you want to introduce additional tiers or additional throttled or mapped topics in the future, because you have to update your front-end applications, you have to publish those changes, you have to wait for your clients to be updated. Now, with Diffusion 6.7, our latest release, we introduced a new feature called session trees. And what this does is it allows us to map particular subscriptions to different topics based on the user who's subscribing. So let's say we have an event feed and we have a source topic. Maybe that's our tier 1 feed because it's the full raw live data happening as it's being published. And then we have a throttled topic, one update every second or every 5 seconds. We'll call that the tier 2 topic. Now, on our front-end applications, we can code them to only subscribe to just the match topic. There's no concept of a tier in this part of the application. What we do in Diffusion is look at who's connected, and we say, if this is a tier 1 user, when they subscribe to the match topic, they should get the source. And if this is a tier 2 user, when they subscribe to the match topic, they should get the throttled one. Now we can define who a tier 1 and tier 2 user are through various different mechanisms. We can use authentication handlers, we can use client properties. There's a variety of different ways that I don't want to get into too much detail on now, but for the purposes of this demonstration, we can just use the principle. So let's look at adding this in, and let's just look at this demo application one more time and cover the fact we're connected as a tier 2 user, and we're subscribed to the tier 1 and the tier 2 topics. And if we unsubscribe from tier 2 to, so in our sessions tab, we can go to the session trees feature, and we'll add what's called a branch mapping. So our source is going to be so we can say if the principal is tier 1, we can add the source. And if the principal is tier 2, we can add the throttling. Now, I just want to make sure that we've got this exactly right. So what we're saying is that the source branch will be mapped. And then depending on what the principal is, they'll be mapped to a particular target topic here. Now we can make sure that we have those set up. In fact, actually, I realized perhaps we should just use the tier 1, tier 2. So let's modify these rules. There we go. So you can see in our mapped topic that we have our tier 1 and tier 2 topics. In our session tree, we have source branch of mapped. And now if I connect and subscribe to mapped, and if I amend the permissions to allow us to just read and modify any topic. So I suspect that there is a very simple aspect of this that I have missed, but at the interest of not holding up this presentation, I will move on from that. Apologies that the demo gods didn't smile favorably on us. But this session tree model is something that we have customers using today, precisely to offer multi-tiered data feeds in a way that's completely transparent to the end application. And what that means is there's now a very low development cost to managing and playing around with the different quality of data feeds you can offer to your end user applications. You can apply throttling or other topic views. You can split apart your data or remap it. And then you can provide that completely transparently to your applications. And you can make changes to those, to that wrangling, to that throttling, completely on the fly without requiring any further development effort on your applications. It makes it very quick to test new ideas, to validate that performance characteristics are within requirements, and enables you to introduce new product capabilities and new tiers of service without having to do any hard development. So let's recap what we've covered today over the past hour. Looking at the quality of service for consuming event data, we can see how throttling and conflation means that you can now independently manage the update frequency of events between upstream sources and your downstream consumers, and how you can provide different tiers of update frequencies to different types of consumers. We've seen how we can use data enrichment capabilities in Diffusion to provide granular subscriptions to let users subscribe to very specific parts of your data model without having to do any transformation on your event stream before it goes into Diffusion. That removes any coding effort that you might need there. We've seen how Diffusion's real-time security model gives you a very broad control over precisely what data particular clients can see at any given point in time, and how you can change that on the fly. And finally, we've covered how session trees let you transparently present all these different tiers of service to applications without requiring any specific development or per tier alteration at the end user level. So hopefully this has been a useful introduction to some of the various capabilities that Diffusion has managing the quality of service for event-driven applications. If this has been interesting to you, then great. We have step-by-step tutorials with source code hosted on GitHub available on our website if you want to dive into how to actually use these features yourself. If you'd like to see how some of our customers have been using these features in a more use case oriented way, we have various ebooks, again, on our website that cover precisely that. And finally, if you have an existing application or a new project in mind that you think that these features might be beneficial for, you can sign up and try Diffusion completely for free today. Just go to dashboard.diffusion.cloud/sign up. Thank you, everyone,